To the young ladies in the room, I do apologize. I'm not Jens Hiestermann. I don't know, how I got suckered into this. I'm completely out of my depth. That was supposed to be a joke. Anyway, I'm going to read this because, as I say, it's quite complicated stuff. We're going to try and keep it as simple as possible. So essentially what Jens has been doing is finding a modeling approach for mapping wetlands. In the past, wetland mapping approaches, the classification of satellite imagery has been at the forefront of wetland mapping globally. But the literature illuminates to the fact that there are problems associated and limitations associated with using satellite data for classifications. And the literature also emphasizes the need and importance for using ancillary data. And by this, we're talking about topographical variables like slope, or environmental variables and characteristics like rainfall, or geology, or things that can allow you to look at the probability models in the landscape of wetness potential, in increasing the accuracy of wetland mapping identification. So Jens's study therefore placed a focus on looking at a new methodological approach for building a model using the available ancillary data that relates directly or indirectly to wetland form or function, with the aim, click to next slide, to develop a model of the likelihood of wetland occurrence in KZN wildlife using conditional properties derived through a Bayesian network. The output emanating from this model of the above study is intended to help refine the wetland layer for KZN. He's quite adamant of the fact that it's not a replacement for it, it's just a refinement. Why are you giggling? Okay, he did a lot of hard work. This is an oversimplification of Jens's work. I know because he's tried to explain it to me and I didn't understand it. But essentially, you build a statistical model using all the ancillary data. From this, you chuck out the rubbish or the redundant data. Then you translate that into these various states, plug that into a Bayesian network, and this is where he did all the clever mathematical modeling, as far as I remember, or good maths, and he came out with a final wetland probability layer. I do need to talk to him about his choice in literature, but essentially the darker areas are the higher probability of wetlands. And according to him, he thinks this might be a pretty good reflection of what is there, but I'll go into that in more detail. Okay, he's just highlighting various examples here of where it is picking out known wetland areas. Zooming in, just to check really if that's a true reflection. On closer visual inspection, it reveals that this does a fairly good job at accurately identifying actual wetland systems that we know of quite well. Musi swamps, Pongola floodplain are two examples. Okay, in the Natal Midlands, this is a fairly well-mapped area in terms of wetlands, and he's done a comparison there. It's the most well-mapped region in KZN that he knows of. So here he says it's evident that there's a high probability that the high probability values correlate closely with the mapped wetland areas in the area. So he's saying his model fits the actual data quite well. In a poorly mapped area further down the south coast where the wetlands have not been as well mapped, they're not well mapped mainly due to the high transformation in that area. Very few wetlands in this area have been mapped, but he says here that the probability layer suggests that there may be far more wetlands, especially in the paddocked area around the town. Yeah, you can see he's picking up these. Can you see the green patches from where you are? Okay. Okay. Sorry about this, but this is very different stuff to what I usually do. He did do a probability assessment, an accuracy assessment on his model, but he can't go into the details of that at this stage. But this is a case study he chose to zoom into where there was a photo-referenced area that had not been identified in the KZN 2011 KZN wetland layer. which is the green polygons are the wetland area already identified by the 2011 KZN layer, these areas here. So those had been identified previously. The red polygon is the photo reference wetland, which was not identified in the 2011 map. That's that one over there. And then the orange polygon is the area highlighted with the high probability value of being a wetland. There you go. Okay, so essentially what this is saying is he's picking out areas in his model that are not picked up in the previous assessment. But is that really a wetland? So he went into a Google search image of this and checked it out, and through the experience of him and his colleagues, they suggested that this is indeed a wetland area that his model is picking up that wasn't picked up in the previous assessment. But he says it does obviously require a quick field visit, but my guess is by looking at this image that it is indeed a wetland. That's quite cool. There you go. So that's the wetland that his model picked out that wasn't picked out in the previous layer. Okay, so in conclusion, this is just a poster presentation, by the way. he concludes that, yes, I think the method and approach used in this study was reasonably successful in the mapping the probability of wetland occurrence in KZN. The method was used in this study is complicated by the overall assessment revealed its potential in improving the current KZN wetland layer. The aim of this method and approach was not to replace the current wetland layer, but to help improve the current wetland layer, and I think this product can therefore be used to this effect. In terms of whether it can be used as a national scale, he's not that sure about this because the model depends very much on the ancillary data that you input into the system, and KZN is it's got a particularly good set of data for that. So in terms of rolling it out to a national system, it's very dependent on the kind of data available for those areas. And I think that was just about it. Thank you. Sorry, I did a hash job at that. He does apologize for not being here. Thanks.
Well, thanks very much for stepping into the breach and running through it.